One of the most common types of questions on the free response and the multiple choice part of the AP exam are problems involving maximums, minimums, increases, decreases, concavity, that sort of thing. So here we've got a question asking where a function is increasing. Remember, a function is increasing when the derivative is greater than zero. Remember, we check for what are called critical values. Those are the places where the derivative changes from positive to negative or negative to positive. And that's going to be places where f prime is equal to zero, or technically it could be undefined and it could also change directions. So you're always going to start out by taking your derivative. And in this case, we have a product. So f prime is going to be equal to derivative of the first is 2x times the second, which is e to the negative x. And then plus the first times the derivative of the second. The derivative of the second is going to be negative e to the negative x. So this is going to give us a negative sign there. We'll have that x squared minus 3, and then we'll have that e to the negative x. All right, and I want to figure out when this derivative is equal to 0. So I noticed here that I can factor out an e to the negative x here. Factoring is always going to be really important, especially if you have a problem that's a non-calculator question. So I'll factor out the e to the negative x. You might want to write that as 1 over e to the x, because that's what a negative exponent actually means. And you've got 2x minus x squared minus 3. And anyway, this will simplify. You'll end up with a negative x squared plus 2x plus 3 being multiplied by e to the negative x. And by the way, e to the negative x, again, is really the same thing as 1 over e to the x. So you may even want to write it as 1 over e to the x now that we're starting to evaluate. Okay, so we're trying to figure out when that statement is equal to 0. Well, 1 over e to the x, you can't ever take e to any power to get a negative. So that's always going to be positive. So we're really just looking for when this is negative. Okay, we can factor that. That's got to be 1 over e to the x. The factorization there, we can factor out a negative 1, and then you're going to have an x squared minus 2x minus 3. And so you'll get an x minus 3, and you'll get an x plus 1. Okay, and then at this point we can take this and we can try to factor this and figure out what is going to make this equal to 0. Okay, so if you think about this, if you set this equal to 0, x could be 3 or x could be negative 1. Okay, those are what are called the critical values of this function. So at this point, I usually like to make a number line with x and f prime. And remember, you just care about the sign of f prime. You don't have to get exact values. So I like to use, substitute some points into the factored version of the equation. I think that's usually going to be the easiest to work with here. So our critical values are at negative 1 and positive 3. And if we start substituting values in, for example, if you put 0 in here, e to the 0 is 1, so you're going to have a negative there. You're going to have a negative there, and then you're going to have a positive there. And that's two negatives being multiplied together will give you a positive. So between negative 1 and 3, your function is going to have a positive derivative. That means it's increasing. Okay. If you substitute in something like negative 2, you would end up getting a negative, and the function would be decreasing. If you substitute in something like 4, you would also get a negative, and your function would be decreasing again. So this function will only be increasing in that range between negative 1 and 3, and that will be option D.